Morning, Algebra 2. This lesson has a lot in it, so hopefully you're following along and watching the video. So lesson 49 covers three different things. The first is something called Pascal's Triangle. And I can use Pascal's Triangle to expand binomials. Okay, another way of saying expand is basically to distribute. It's a shortcut for distributing. So I'm going to help you build Pascal's Triangle. And if you were here, I'd have you complete some of the rows yourself. So the first two rows of Pascal's Triangle you have to memorize. The first row is 1. The next one is 1, 1. Notice that forms a triangle. Now every other row from here on out follows a pattern. Every row begins with a 1, and notice I stagger my numbers. I don't write them right underneath each other. I write them to the side and in between. The next number will be the sum of the two above. So 1 plus 1 is 2, and every row ends with a 1. Next, every row begins with a 1. The next two are a sum of the two above it. So 1 plus 2 is 3. 2 plus 1 is 3, ends with a 1. Next row, 1. The sum of the two above it is 4. Sum of the two above it is 6. Sum, 4, 1. Now I'm going to keep going, okay? And I'll zoom out just a little bit. So 1. The next sum of 1 and 4 is 5. 4 and 6 is 10. 6 and 4 is 10, 4 and 1 is 5, and ends with a 1. Now, we can keep going infinitely. We can continue to build this triangle forever and ever and ever. But hopefully you notice something. Notice that obviously the beginning is all 1s, the ends are all 1s, but also notice something in the next diagonal. 1, 2, 3, 4, 5, but notice those same numbers repeat here. So a 5 is in both the beginning and like it's the second number and it's the second to last number. Same with the 4s, same with the 3s. So based on that pattern, I bet this next one is 6 and 6, right? Because 1, 2, 3, 4, 5, 6, second number, second to last. But these are, again, are a sum. 5 and 10 is 15, 10 and 10 is 20, 10 and 5 is 15. Now I'm going to stop there because I'm running out of room. But I have to explain that each of these rows corresponds to the value of n. Notice n is the exponent, or another word for that is power. Now each row in Pascal's triangle has a value for n. So here would be n equals 0. This would be when n equals 1. N equals 2, notice 2, 2. N equals 3, you got 3's here, 3 here. 4's, 4. Can you guess the value here? 5. And here, 6. Now we're going to use these to expand binomials. So I'm going to do an example with you. We're going to start really simple. Expand. Let's see here. Let's do x minus 4 to the 4th power. And I'm going to change this to a 3. Okay, so expand x minus 3 to the 4th power using Pascal's triangle. Now you don't have to write that part, but okay, so the first thing I'm going to notice is I'm going to label my parts. So for example, I know the first term is A, this term is B, but specifically I'm looking at my power. So because my exponent is a 4, then I know n equals 4. So I'm going to go up to Pascal's triangle and I'm going to copy that row. So from Pascal's triangle, I'm going to copy those numbers. So 1, 4, 6, 4, 1. And I'm going to use those triangles. So remember, what I'm doing right now, is a shortcut to, otherwise I would have to write x minus 3 times x minus 3 times x minus 3 times x minus 3, and then I would have to do 2 at a time, these two, then this one, and it's a lot of work. So this is supposed to be an alternative method. So here's how we're going to set it up. You first start with the first number from Pascal's triangle, so that was a 1, and then in parentheses, we're going to put our terms. So I have an x and a negative 3. Next, I'm going to do the next number from Pascal's triangle, which is a 4. And then again, our terms, x, negative 3. Notice I'm using the negative. Even though it says x minus, we're going to count that as a negative 3. So took care of that. Next one, 6, our terms. 4, our terms. Notice every time I use a plus sign. And last, and then our terms. Okay, now we're going to assign our exponents. So, starting with the first term in the parentheses. Because n equals 4, I'm going to start with n. First exponent equals n. So my first exponent is a 4. Now, when things are written in order, the exponent should then decrease. So if this is x to the 4th, this next one should be x to the 3rd, x squared, x to the 1st, 0. Now, when I do the second term's exponents, I know that the sum of exponents has to equal n. So 4 plus 0 equals 4. 3 plus 1 equals 4. 2 plus 2 equals 4. 1 plus 3 equals 4. 0 plus 4 equals 0. So that is first exponent has to equal n, and the sum of our exponents also has to equal n. So 2 big factors right there. Now let's do some review. Anything to the 0th power is 1. So this is just 1, and so is this. From here, we're going to use our calculators to simplify if you need them. So I'm going to bring down this first term. 1 times x to the 4th is just 1x to the 4th. And do I need the 1? Absolutely not. So I'm going to bring down the plus sign. Well, I'll leave it for now. I'm now going to enter this. So this would be 4, right, times negative 3 times to the 1st times x to the 3rd, right? If I rewrite this, okay, and so using my calculator, you probably don't need it for this one, 4 times negative 3, this gives me negative 12 x to the 3rd, okay? Moving on to the next term, so I have 6, I'm going to write the number next to it, times negative 3 squared times x squared. So I have 6 times negative 3. Notice I put the negative 3 in parentheses, squared. And that gives me positive 54x squared. Notice those x's, 4th, 3rd, squared. Next one. This is 4 times negative 3 to the 3rd times x. So 4 times negative 3 to the 3rd. That gives me negative 108x. And last, I have 1 times negative 3 to the 4th. So 1 times, parentheses, negative 3 to the 4th. Gives me 81, and it was a positive 81. And that is my answer. Okay? So if it helps, like this gave me this, and so on. So I did each term. Now, I hopefully you're watching along because this is going to be hard to get from my notes. Okay, so let's try another one before we jump into our lesson practice. Actually, you know what? No, let's jump into our lesson practice. So page 351, part A wants us to expand 2x plus 4 to the 3rd. So that means that n equals 3. So from Pascal's triangle, n equals 3, my numbers are 1, 3, 3, 1. So 1, 3, 3, 1. So let's set it up. The first thing you do is grab the number from Pascal's triangle and then our terms. I have 2x and 4. So 2x and 4. So next 3 and then our terms. 2x, 4. Next 3, 2x, parentheses 4. Last 1, 2x, parentheses 4. All right, now I'm going to sign my exponents. Remember, whatever we found was n is our first exponent. Then I'm going to go in descending order for x. X cubed, x squared, x to the first, 0. Now, the opposite is true for the second term. The exponents actually increase. So for the first term, they go down. For the second term, the exponents are increasing. Remember, their sum has to equal n. So 3 plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. 0 plus 3 is 3. Anything to the 0th power is just 1, so these are gone. And then I'm going to simplify. Now watch what I do here. This is 1 times 2 to the third times x to the third. Now that is an exponent property from a long time ago. If I have 2 terms in here, both of them have to be raised to the third. If you need your calculator for that, I'm not going to enter 1, but 2 to the third gives me 8. So this becomes 8x cubed. Okay? And then I'm going to bring down the plus sign. This next one, this is 3 times 2 squared, because 2 is squared, times 4 to the first power, times x squared. I write my letter last because in my calculator I'm going to enter all the numbers. So 3 times 2 squared is 4, right? So and then times another 4. I don't like to enter any more buttons than I need to. So I put 4 here because 2 squared is 4. And I get 48. So 48x squared. Now this method is fast for those of you who can do your multiplying and your powers quickly. This next one, so this is 3 times 2 to the first, right, because each of these is raised to the first power, times 4 squared times x. So that's 3 times 2, 2 to the first, times 4 squared, and I get 96, so plus 96x. And these are all positive. There's no negative numbers in my binomial, so there should be no negative numbers down here. Last, this is gone, so I have 1 times 4 to the third, which I know is 64. I've done that enough to know the answer. All right, next one. I want you to have plenty of practice. So part B. And I'm not really going to pay attention if the book says use the binomial theorem or use the Pascal's triangle. I'm going to go over what's easiest and when we need each method. So part B has us doing f plus 2 to the 5th. So there's a glare there, I apologize. So that exponent right there tells me that n equals 5. So 1, 5, I don't have it memorized, 10, 10, 5, 1. So we have a lot of terms in this one, but remember the setup. It's the number from Pascal's triangle, and then your terms. Number from Pascal's triangle, then your terms. Now notice this is a plus sign, so there shouldn't be any negatives in our answer. So 10 terms. Next, 10, 5, 1. Now, see if you can assign your exponents. Remember, you start with n. So if you want to pause, try plugging in your exponents for both f and for 2. All right, so for the first f, it should be 5, right? If this is 5, n is 5, so this first exponent is 5. So for the f's, 5, 4, 3, 2, 1, 0. So I'm going to cross that out as I do it. Okay? Now my exponents must add up to be n. So 5 plus 0. 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4, 0 plus 5. So let's simplify each term. This is gone, so 1 times f to the 5th is just f to the 5th, right? That one's pretty simple. This one, I have 5 times 2 times f to the 4th, so that would give me 10f to the 4th. This is 10 times 2 squared times f to the 3rd. That's 10 times 4, so 40f cubed. 10 times 2 to the 3rd times f squared. I know 2 to the 3rd is 8, but if you need to use a 2 to the 3rd times 10, 80. So 80 f squared. Sorry, I'm trying to show you where each of these terms is coming from. 5 times 2 to the 4th times f. Now I know 2 to the 4th is 16 times 10, times 5. So this is also 80f. This last one is just 2 to the 5th, which is, not 36, is 32. So this right here, I ran out of room to, is the answer. All right, next one. We don't necessarily need to do all, but I want to. So they want us to expand 1 minus 7x to the 3rd. Based on the exponent, I know n is 3, so 1, 3, 3, 1. Because that's the row from Pascal's Triangle. So I would like it if you paused the video and try to set it up and then check your work. Okay, that is going to be the most effective way to learn it. But I'm using the numbers from Pascal's Triangle, then my terms, and keep them in order. 1 is listed first, so I wrote 1, then negative 7x. Then 3, 1, negative 7x. Another 3, 1, negative 7x. Last 1, 1, negative 7x. You can pause it now, do your exponents, okay? So 3, 0, 2, 1, 1, 2, 0, 3. Notice for the ones, it's decreasing, and for negative 7x, the exponents are increasing. So again, cross out anything to the 0th power. So let's simplify each term. This is just 1. This is 3 times 1 times negative 7, right? This is negative 7 to the 1st power. So that gives me negative 21x. 3 times 1 times negative 7, and I just have x to the 1st power. This is 3 times 1 times negative 7 squared times x squared. So you might need your calculator for that, right? 3 times 49, because negative 7 squared is 49. So I get a positive, because a negative times a negative, so positive 147x squared. Okay. Next, or the last actually, is negative 7 to the 3rd times x to the 3rd, right? That's all you have left here. So 7 to the, parentheses, negative 7 to the 3rd is negative 343 x cubed. And that, I know it looks crazy, is your answer. Now, for the remaining of our work, we're going to be using the binomial theorem, which is what the section is called. So I'm going to add a part to Pascal's Triangle. Each of these terms has a combination equivalent. Now, combinations are written NCR. Notice the N and the R are lowercase, C is capital. So for this value here, this is 0 because N is 0, right? We know what N is. These are our values of N. And the first R is always 0. So if I was to enter that, so I have to go 0 probability. I get, notice, sorry, my screen timed out, so let me log back in. My apologies. So 0C0, look, I got the number above it. So for the next row, N is 1, so this is 1C0, 1C1. This last number can never be greater than what N is, okay? So I always start with the first R is always 0. So if I was to enter 1C1, guess what I would get? 1. So this next row, N is 2, so 2C0, 2C1, 2C2. Again, this should equal, so I'm going to enter 2, probability, NCR, 1, notice, and look, I get 2, the number above it. They should be equivalent. So this next row would be 3C0, 3C1, 3C2, 3C3. Now I want you to notice that every single combination started with our value for N, and the second number always begins with 0 and counts up. So 0, 1, 2, 3. So you can pause the video and try to fill in the next row, beginning with 4C, and you write the first number and fill it in. So this would be 4C0, 4C1, 4C2, 4C3, 4C4. Again, if I was to enter this combination 4C2, I would get 6, okay? So try the next 2 rows. You can pause it and then come back and check what I have. Whoops. Michelle. Look at me. Just filled in this wrong. Just minding my own business. I was actually thinking about what I was going to have to cook for dinner tonight, so I got distracted. All right, so we are going to use this for the next part. So let's clarify. To expand, use Pascal's triangle. To find a single term, use the combinations. So I'm going to do an example with you before we do what's in the book. So I believe I only did one example with you before we jumped into lesson practice. Yes. So, for example, if I asked you to find the fourth term of, this should say third, of x plus 6 to the 7th power. So I know that x plus 6 to the 7th power has a million terms. They're wanting the third. So here's what I would do. I know that n equals 7. So 7C0, 7C1, 7C2, and I could keep going, but they ask for the third term. This would be first, second, third. So that is the combination I'm going to use. So 7C2. Then I'm going to set up my terms. And now I have to plug in my exponents. So a couple little tricks for you. R will equal the second exponent. So that means that the 2 is here. Okay, so R will equal your second exponent. And also remember our exponents, the sum of exponents has to equal n. So 2 plus what is 7? Well, 2 plus 5. So I'm now going to enter this in my calculator. So enter 7C2 in your calculator. So 7 combination, and I get 21 times 6 squared times x to the 5th. And so that gives me 21 times 36 is 756 x to the 5th. And so that is the third term of that expansion. So let's try one more before we do the lesson practice. Find the 6th term of x minus 5y to the 9th. Woo! Right? Crazy, crazy. So I know that n equals 9. So 9C0, 9C1. Don't just assume it'll be NC6. No, 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 no. Write it out. Find the 6th one. NC2, NC3, NC4, NC5, NC... Whoops. So first, second, third, fourth, fifth. This would be the 6th term right here. So 9C5, my terms, x, negative 5y. I know that this r must be my second exponent. Remember, these should be the same. And then these exponents have to add up to be 9. So 5 plus 4. So the second should match, the sum should be the first. So then I'm going to enter this in my calculator. So 9C5 is 126 times negative 5 to the 5th, right? Times x to the 4th times y to the 5th. And I don't need parentheses here. So I'm going to enter this, what I have left in my calculator. I'm going to get a big number. Shame on me. I just picked, so negative 5 to the 5th. Woo! So negative 393,750 x to the 4th, y to the 5th. So let's go back to our lesson practice, part D, and we'll finish our notes. And we are going to get into probability. So hopefully you have your book. Sorry, that was a notification for me. All right, so part D. It says find the 4th term of x plus 3 to the 10th. And I'd like you again, pause and try it and then look back at what I get. So I know that n equals 10. So 10C0, 10C1, 10C2, 10C3. That right there is the 4th term, right? 1, 2, 3, 4. So 10C3, then our terms. The second number must equal the second exponent. And then my exponents must add up to be 10, so 3 plus 7. So using our calculators, 10C3, I got 120. So 120 times 3 to the 3rd times x to the 7th. I got 3,240 x to the 7th. All right, now the rest is for probability. So using combinations for probability. So this is how it's set up. MCN, P to the N, And don't worry about their fancy, crazy. But the first term should be the probability of what we want succeeding, or the success. And the second one should be the probability of it failing, or what we don't want to happen. So the easiest, we're just going to jump right into our lesson practice E. And I accidentally shut my book, so please I apologize. But let me go to lesson 49 really fast. Okay, so here I am. It says, find the probability of getting exactly 5 tails if tossed 6 times. Okay, so here's how we're going to set it up. I am tossing it a total of 6 times. So 6 is going first because that's total tosses. I want exactly 5 tails. Now I'm going to multiply this by the probability of what I want happening. So what's the probability of getting tails? Well, there are 2 sides on the coin, but only one of them is a tail. So inside, I'm writing the probability of getting tails. So this right here is the probability of tails. Now, we're going to set this one up different, okay? I'm wanting, and we could switch it around later, but the probability, I'm wanting to get 5 tails. So the probability of not getting tails would be the probability of getting heads, right? Heads is the other side. And the probability of heads is also 1 out of 2. But I'm only tossing it 6 times, so this is 1. Now I recognize that these don't match, but if I switched and listed this one first, then it would match, okay? So I would then enter all of this. So 6C5 times, that was 6. 1/2 to the 5th, 1 to the 5th is 1. 2 to the 5th is 32 times 1/2. So I'm going to simplify this. 6 times 1/2 is 3. Times 1/32 would give me 3/32. Now, I know that one was confusing. I get it. So let's now move on to part F. What's the probability of getting at least 1 tail if I still toss it 6 times? Now, when it says at least 1 tail mean I want either 1, 2, 3, 4, 5, 6. I don't want 0 tails to happen, okay? So here's how we're going to set it up. Because it says at least, it is much faster to do this 1 minus the probability of what I don't want. So that's how I'm going to set it up. 1 minus the probability of getting 0. So 1 minus, so I'm tossing it 6 times. The probability of getting a 0, because would be 0 times. Remember, I have heads and I have tails, right? Heads and tails. So this is heads, this is tails. Now, if you want, you could match this one. That's a probability of not getting tails. This is the probability of notice those now match. So 1 minus 6C0, what's the first term in every row? 1. And this would be 1/64. And this is gone. So 64/64 minus 1/64 equals 63/64. That's almost a whole. So the probability is very likely of getting at least 1 tail. G, they showed us a spinner. The spinner looked like this. And it asked, what is, if I spin 4 times, what's the probability I get white 1 time? So here's how you would set it up. The total amount of times I'm spinning it, I want white 1 time. So I have to do the probability of getting what I want, which is white, and the probability of getting what I don't want, which is black. So this is what I want. This is what I don't want. So the probability of getting white, there are how many white sections? There are 3 out of 1, 2, 3, 4. The probability of landing on black is 1 out of 4. Now, I want to get white 1 time, which would mean that this would be 3, because 1 plus 3 is 4. Now, again, I know these don't match, but I could switch these because multiplication order doesn't matter. So 4C1 equals 4. So I have 4 times 3 over 4 times 1 over 64, because 1 cubed is 1, 4 cubed is 64. These cancel, and I end up with 3 over 64. All right, for your homework, yes, we're finally done. Skip 11, 13, 18, 21, 23, and 26. Sorry this was so long.